Hi everybody, welcome to Chapter 1 in Algebra 2. We're going to start off this chapter with actually combining two sections. We're going to combine Section 1 and Section 2, mainly just because Section 1 hopefully will be a quick review, and Section 2 has a lot of things you guys have seen before, but maybe it's just been a while, about different types of numbers and how we can classify numbers. So we're just going to go through that pretty quickly. So let's just go ahead and get started. So the first thing that I want to go through is just a reminder of what a couple things are here. First, what's a variable? Okay, a variable, hopefully we all remember, is going to be a letter, and it just represents a quantity. Okay, so typically you're going to see X or Y as our variables. You could see any letter though, it could be A through Z, as long as it's some letter that's representing a quantity in an equation. All right. And what's going to be very important throughout this year, but especially this semester, is going to be PEMDAS. So hopefully you remember what PEMDAS stands for. A lot of people remember it as please excuse my dear Aunt Sally. Remember, it's parentheses, exponents, multiply, divide, add, and subtract. All right, so it's going to be really important that you guys know that as we start to develop more complex equations throughout the year. But what we're going to start with is just something really simple where we're going to evaluate an equation given a set of information. So here it says evaluate m plus p minus 1 squared if they tell you m is equal to 3 and p is equal to -4. So anytime they ever say evaluate, all that means is basically you're going to take what they give you and plug it in or simplify it. So anywhere I see an m, I'm going to replace it with a 3. So I'd have 3 and then plus, and everything else stays the same. And then wherever I see a p, I'm going to replace it with a -4. So -4 minus 1, and then all squared. Now notice I kept the parentheses, and it's really important because if you, as we get into later problems that are a lot more complex, if you have to rely on a calculator, it's going to be really important to know where parentheses are necessary and where they're not. All right, so don't get rid of those unless it seems like it would be okay to get rid of them. And really and honestly, to be safe, I would just keep them most of the time if they're already there. All right, and now we're just going to go through the PEMDAS process to simplify this. So obviously in PEMDAS it says parentheses first, so we're going to go ahead and simplify what's in the parentheses. So we'd have 3 plus -4 minus 1 is -5, so we get -5 squared. Keep in mind I kept the parentheses as is, okay, just to make sure that I'm keeping it as close to the original as possible. And then I'm just going to follow through. So next would be the exponents. So what is -5 squared? This is where I said the calculator and the parentheses is really important. If you were to just to type in your calculator -5 squared, you might end up getting that it says -25. And if you remember what squares are, it means it's a number times itself. Well, two negatives, when you multiply them together, get a positive. So that's why when you type this in a calculator, you have to have the parentheses around the -5. The calculator doesn't quite understand that you want that negative to stay with the 5, so it kind of just throws it on the outside. All right, so if it's got parentheses and your calculator allows you to use parentheses, then always use them if you can. All right, so -5 squared, that's going to get us positive 25. So we're going to end up with 3 plus positive 25. And then, of course, no multiplying or dividing. We're back to adding and subtracting. So we add and we get 28 as our final answer. Okay, so I know most of you guys could do that very quickly. Obviously, that's a little bit more of a simplistic problem, but just an emphasis on the order that we do things and being careful if you ever type anything in a calculator to use those parentheses when possible. Okay, now I do have an extra example here if you feel like you need a little bit of practice. This one's a little bit more complex than the one I went through, so if you want, you can go ahead and write this in your notes and get your answer, and if you'd like me to check it in class, I will gladly go through that with you. But if you feel like you're pretty confident, you can go ahead and move on with me. So the next thing we're going to talk about are different kinds of numbers. Now I realize there's a lot of vocab words here, so just kind of bear with me as we get through them. But basically we're going to talk about the types of numbers that we have and that we're going to use and that you're pretty much going to see all year. And honestly, you see these all the time. You may just not even know it. So the first thing we're going to talk about are real numbers. So real numbers are basically just all the numbers. So that's a really generic category. Real numbers encompasses every kind of number that you could pretty much think of. Where we start to get more specific is where we go down this line. And at the bottom of the screen, I'm going to have a little diagram that kind of shows how they're all related. So don't worry if you're not sure about where everything belongs quite yet. So rational numbers, the second one I've got right here, this one is basically when you take a number and it can be written as a fraction, as a repeating decimal, or as a terminating decimal. And what a terminating decimal means is that the decimal ends, okay? It doesn't go on forever. So some basic examples of rational numbers might be something like, let's see, negative 27. Okay, that could be written as a fraction as negative 27 over 1 or as a decimal 0.0, okay, but this would be a rational number. Another rational number would be something like 2/3, okay. So 2/3 is a fraction, so we can consider it a rational number. A repeating decimal might be something like this, a negative 0.3333 repeating. Okay, so notice there's a pattern. It goes on and on and on, but it's all the same numbers repeating. Now, it doesn't have to be the same numbers, but as long as there's a pattern of repetition, that's what we're looking for. Okay, so these are just a couple examples. Next is our irrational numbers. Now, irrational numbers we're going to talk more about in either at the end of this semester or the beginning of or some time next semester, but all you really need to know now about irrational numbers is that it's when you take a number that does not end or repeat. Okay, so it's kind of the opposite of the rational numbers, obviously. Okay, so an example of an irrational number might be something like pi. Pi, as if you remember pi from geometry and things like that, that 3.14, and it goes on and on and on forever. There's no repetition and it doesn't end. Okay, so that would be irrational. So I'll write that. Another example might be something like a square root that's not going to come out nicely. For example, maybe I say the square root of 21. Okay, well, the square root of 21, if you type that in your calculator, is a really ugly number, and it just kind of keeps going. So that would be considered an irrational number, right? Next is our integers. Integers, you guys have been working with integers for a long time. All integers are just positive and negative numbers. So that would be anything from the negative 500 up to positive 100,000. Okay, I'm just making up numbers. But as long as they're positive and negative. Now notice the difference between integers, okay, so notice there's positives and negatives, and rational numbers is that integers they can't be fractions. Okay, so this is a little bit more specific. Whereas here, they can be positive and negative, but notice they can also be written as fractions. So there are more types of rational numbers than there are integers, okay, because integers have to be whole numbers, which leads to our next definition. Okay, whole numbers are anything from 0 up. Okay, so 0, 1, 2, 3, 4, 5, all the way up to whatever, okay, but no negative numbers. So I'll put this here, no negatives. And I'll put this here as like, this is not the only specific thing, but no fractions, okay, or decimals for these types of integers. Okay, and then the last one is the natural numbers. Okay, basically what you first started learning when you were little, and that's the natural numbers of 1, 2, 3, 4, all the way up to any positive number. Okay, so there, the major difference is you do not include 0. All right. And I pulled this from your textbook, so you guys can always go back and look at this if you want. But this is actually the diagram that they gave in your textbook. So notice that it just kind of shows you how everything's related. So it says real numbers at the top because all of these things are real numbers. Okay, but then it goes kind of into its more specific category. Now notice irrational numbers are just off on their own. They're not related to these other three. So rational numbers is the biggest category. Okay, you can fit the most in there, positive and negatives. Okay, but then you get into more specific things, which are integers. Okay, here they can be positives and negatives, but they can't be fractions. Okay, and then we get into whole numbers, which would be only our positives. Okay, so and notice it gets more specific the smaller we go. Okay, so this is a good reference if you're not sure. And the reason we're going through these is because here in a minute we're going to be classifying these numbers. And later, when we get into more complex sections, it's going to be really important that you recognize what kind of numbers you're working with, and especially as we get into your irrational numbers as well. All right, so I have 3 examples here. We're just going to practice classifying them. We'll get more practice in class as well if we need it, but we're just going to go through the list. Now, when it says to classify a number, keep in mind that it may have more than one classification, okay? It might fit into more than one category. So let's start with A. It says negative 23. Well, right away, okay, we know it's negative. Okay, so if we go back to this, we know it can't be whole numbers, okay, and it can't be natural numbers because those can't have any negatives in them. So if we know it can have a negative, automatically we know it can be an integer. Okay, so we can write that it's going to be an integer. And we know that if it is an integer, okay, that means it can also be a rational number, because remember, rational numbers can be positive or negative. So I can write that it's a rational number. And because it's a number in general, we know that it's real. Okay, negative 23 is a real number. Okay, and then we'd be done. So those are the 3 categories. It's an integer, it's rational, and it's real. Done. Now, the square root of 50, okay, if you're not sure what the square root of 50 is, okay, you could always go to your calculator, type that in. So let me see here if I can do that real quick. So take the square root of 50, we get 7.07106, and notice there's no repetition here. It keeps going. Obviously our calculator stops it, but this would keep going if it were able. So because there is no repetition, it's not a fraction, okay, this automatically means that it's going to be irrational. And remember, irrationals are also real. Okay. All right. Then next, we're going to be talking about fractions here. So we got a negative 4/9. Okay, remember fractions have to be rational. Okay, so we can write that right away. So rational. And we also know this is a real number. Okay, we can have a fraction in real life. Okay, now, can it be an integer? Well, we said integers were negatives, okay, but the rule says that integers can't be fractions. That's too specific. So in this case, we only have 2 classifications. It's rational and it's real. It is not an integer because it's a fraction. Okay, integers are gonna be the whole numbers. All right, so that's just 3 examples. Obviously, there's millions and hundreds of millions of numbers out there that we could try to classify. We might do a couple in class, but if you have any questions about how these are classified, please just make sure you ask me in class or go ahead and email me.